screen. This Good morning. Our today's lesson is going to come from DC circuit theory, and we're going to tackle series circuits. And the objective of this unit is like by the end of the lesson, the learner should be able to calculate unknown voltages, current, and resistance in a series circuit. In a series circuit, the current is the same in all parts of the circuit, and hence the same reading is found on each of the ammeters shown. And also the sum of the voltages, that is voltage 1, voltage 2, and voltage 3, is equal to the total applied voltage. That is, V, which is the total voltage, is equal to V1 plus V2 plus V3. So V1, V2, and V3, if you add, you find the total, which is VT. So that is how we find voltage in a series circuit. Pardon, my laptop is hanging. Kindly. Then from Ohm's law, we have V1 is equal to, that is when you find voltage 1, it is current by resistance 1. Same to V2, which is current I by resistance 2. Same to V3, which is I, which is current by resistance 3. And in this case, voltage, you know, is IR, where R is the total circuit resistance. Then since V is equal to V1 plus V2 plus V3, as we've said earlier, then IR, which is current, is equal to IR1 plus IR2 plus IR3. That is to find the voltage. So dividing throughout by I, which is current, we find that resistance is equal to resistance 1 plus resistance 2 plus resistance 3. Hope you are together. I don't know what the silence means, but I think we are okay. And then continuation. For the series circuit, the total resistance is obtained by adding together the values of the separate resistances. That is resistance 1, resistance 2, and resistance 3. So we have example 1. For the circuit shown in the figure 5.2, determine the battery voltage V. B, we have the total resistance of the circuit, and C, we have the values of resistance, that is R1, R2, and R3. Given that the potential difference across R1, R2, and R3 are 5 volts, as you can see from the circuit below, then we have for the PD across R2 is 2 volts. Then from the PD across R3 we have 6 voltage. Hope you are following whatever that is written in that circuit. So let us do that example. So in this case we have to find the battery voltage. We find that voltage is equal to V1 plus V2 plus V3. So in this case V1 from that circuit you can see it's what? Yes, it's 5. Then V2, we have 2 volts. And then V3, we have 6. So when we add V1, V2, and V3, we find that the battery voltage is equal to 13 volts. Hope you are together. Then B, the total circuit resistance. In this case, from what we've learned, resistance is equal to V divided by what? Current. So in this case, the total battery voltage, in this case, what we've gotten from our R is the battery voltage is 13 volts. In this case, we've been given resistance, which is 4. So we divide by voltage by current. Then in this case, we find that the total circuit resistance is 3.25 ohms. See, we have resistance R1. For resistance R1, it is V1, you divide by the what? The current. And in this case, our V1 from the circuit is what? 5 volts. So it is 5 volts, we divide by what? Our current, which is 4. So in this case, our resistance R1 is equal to 1.25 ohms. Okay, let me do all these examples, then I'll give you an assignment of the same so that you go and do it by your own. Then we have we've done resistance 1. Now we do resistance 2, which is R2, and in this case it is V2, that is the battery voltage of V2 divided by current. And in this case V2 is 2 volts, we divide by our current, which is 4. We get it is 0.5 ohms. Hope you are following. Then finally we have resistance R3, and it's as simple as we've done R1 and R2, which is V3 divided by current, and V3 is 6 divided by 4. Then we find our answer is 1.5 ohms. Hope you are okay and you are following. Let us do another example, which is example 2. For the circuit shown in figure 5.3, determine the PD across resistor R3. If the total resistance of the circuit is 100, determine the current flowing through resistor R1, and also find the value of resistor R2. So in this case, the potential difference across R3, V3 is equal to 25 minus 10 minus 4, which is equal to 11 volts. And current, in this case, we find current, you know current is V, which is voltage, divided by resistance. So to find the current, it is now the voltage, which is 25, divided by the resistance, which is 100 ohms. And we find that our current is 0.25 amperes. Which is the current flowing in each resistor? You find that resistance R2 is equal to voltage divided by current, which is 4, divided by that current that we found, which is 0.25. Then in this case, now we find that our resistance, which is a resistance R2, is 16 ohms. Then in this continuation on that circuit, the total resistance now, we have resistance 1, 2, and 3. And in this case now we are adding, since they are in series, we add. So it is 4 plus 9 plus 11, then we find 24 ohms. Then in this case, current is equal to voltage over resistance. Our resistance is 24 and our current is 12. So we divide 12 by 24 and we find our current is 0.5 amperes, which is the current in the 5 ohm resistor. So this 0.5, the 0.5 amperes is the current in which is the current in the 9 ohm resistor. So the potential difference across that 9 ohm resistor, in this case, we have V1 is equal to that current by 9, which is the resistance. So it is 0.5 by 9 to find 4.5, which is our potential difference across that resistor. So I think we are done. I'm going to send you an assignment, but before that, any question, enquiry on this point. I'm trying to peana query.
Mwalimu, we are okay.
Okay, let's meet next lesson. Have a nice
Excuse me.
Yes?
Yes, Mwalimu, I'm asking, in case now you have mixed circuits,
Yes.
how do you go about it?
Okay, for mixed circuit. Okay, time is up. Let's meet next lesson. Kindly, then I'll answer your question.